All right, once again, good morning to you all, and welcome to this Monday plenary of week 3. I'm mindful that it is President's Day today, and therefore some kind of legal holiday. Well, that said, as you know, I'm lecturing on Monday plenaries in order to sustain our very special online schedule this term, and the only week where we will not have a Monday plenary will be the week of spring break, where there are no classes for that entire week. And therefore, the cancellation of Monday will not interfere or desynchronize your breakout groups. But meanwhile, those of you who are here, good for you. I admire your work ethic. Those of you in the across the plenary sections who have taken the legal holiday as you're entitled to, no problem. I'll be uploading today's lecture to YouTube as soon as it's available later on today. And then hopefully everyone will get a chance to see it. So just to recap how we got here with Paul Churchland today and his reading on Eliminative Materialism. The epistemology that we began with, this philosophy of knowledge question, has led Descartes quickly, as you saw, to an ontology of dualism, substance dualism in particular, where he believes there are basically two kinds of things in the world, namely thinking things and extended things, or as we would say, perhaps minds and bodies, and that minds are made of something very different than material things. In week 2, we had a look at a very radical idealist named Berkeley, who is an empiricist, unlike Descartes, who's a rationalist. Berkeley's an empiricist, but he argues, as you've seen very closely, that the only possible experience we have, and therefore the only possible knowledge we have of the world, is mental, because it comes through our perceptions, but ultimately our perceptions allow us or lead us to form ideas about what's out there, so-called out there, and we can't really be sure anything is out there. We only have ideas about what's out there. And the only evidence we have is the evidence of the senses. But there is no material substance as far as Berkeley is concerned, because the only experience we have of our own being and of everything in the universe as we perceive things is ultimately an experience of the ideas we form. And so ideas for Berkeley are the only thing of which the universe is made. And continuous existence, therefore, depends on perception. And our ideas about perception, continuous existence, as we saw, depends upon continuous perception. And since God perceives everything continuously, that's the only reason why everything continuously exists. So that's Berkeley's very interesting and very radical view. And now we're going to contrast Berkeley's idealism with a very kind of hard-boiled materialism. And now, by now, some of you may well be accepting of Descartes' dualism. Many of you may have grown up with it kind of implicitly. It's embedded itself in a lot of people's thinking, the idea that there are minds and bodies. It's less common, far less common for people to subscribe to Berkeley's theory, although there are idealists. Certainly there are idealists in the world, not only in the Western world, there are fewer of them. By idealists, of course, I mean ontological, not political. And there are idealist schools in India as well, in that branch, very ancient branch of philosophy, but it's less common. And in the West, we certainly are inundated with theories of materialism. And many of you may be more wedded to the notion that there is a reality out there, it's made of stuff. Hylas's version in Berkeley's dialogue, Hylas, who believes that existence doesn't depend on perception. There are things that exist independently of whether they're being perceived or not, and that's because they're made of some kind of stuff, and that stuff also exists independently of any perceiving minds. And that's perhaps the more widespread view, certainly more widespread than idealism. And it's also become a scientific view in recent decades. It used to be the case, I think, that in the history of science, certainly, that many, if not most scientists earlier on were dualists who believed in an extramental material reality, but also believed in God. So there was a kind of dualism there because God, of course, was non-material and gave rise to the material world. So that was a kind of dualism. It's now become more fashionable not to believe in God among scientists, not all, but I think maybe a majority today try to give us materialistic explanations for everything without recourse to introducing any kind of supernaturalism. And therefore, without introducing any kind of a creator or a super being, such as God is purported to be. So we're going to get this from Churchland today, and his wife also. Paul and Patricia are a pair. She has a reading in there too, in your textbook, which you can look at. But Churchland's materialism, both of them, is more radical than the usual form. And we'll see why. He wants to make an argument for why what he calls eliminative materialism is actually more suitable and more appropriate for our contemporary scientific outlook on things. And so he continues to be an exemplar of a very different philosophy than we've seen from Descartes and Berkeley, but he's also a radical in his own way. I want to introduce you to these very far-fetched, as it were, kinds of positions, just so you could see how many possible extremes there are when it comes to epistemology and ontology. So we'll see what it is he wants to eliminate. Maybe some of you have done the reading, you already know, but if you haven't yet done the reading, we'll be seeing this morning why he's calling his brand of ontology eliminative materialism and not simply materialism. All right, so before we dive into Churchland, are there any questions so far? Everybody all right? Is everybody okay?
Yes.
All right, you're good. Fine. In that case, I may be interrupted by a phone call, and if I am, I apologize. But I will endeavor not to speak long on the phone. So here we go. I'm going to share the screen with you so you can have a look at the reading. And hopefully that's working this morning. Seems to be. So you can all see this, correct?
Yes.
Fine.
Yes.
Thank you very much. So we're looking now at Churchland's Eliminative Material. As I said, his wife, Patricia, and he have both written books on this and articles on this. They both agree, and they apparently converse using their own suggestions, as we'll see shortly. They've eliminated from their vocabulary terms which they deem to be misleading, if not obstructive to our understanding of what the brain is doing. Back to that word understanding, right? Remember, it keeps coming up and it will continue to come up during this section of the readings. All right, so Churchland is a contemporary philosopher. He's getting on, but he's still, as far as I know, around at University of California, San Diego, Canadian originally, and in San Diego for many years. And he and his wife are going to illustrate by argument that what they call folk psychology, namely people's common sense notions of how the mind works, is really been a misleading and an in some ways, an obstructive impediment toward our understanding of brain. And what he really hopes is that neuroscience, which is in a sense in its infancy, as a science, neuroscience or brain science has yet a lot to discover, obviously, about how our brains work. And he believes that a mature neuroscience will essentially be able to give us a complete account of how the brain works, and therefore will denecessitate any kinds of conversations that we might want to have in what he calls a folk psychological domain. So any kinds of discussions of psychological terms that are very vague and fuzzy, starting with the word mind itself, and going on to many other things, would essentially become eliminated once we have a better understanding of the brain. And he wants us to get a head start on this eliminative process. And he'll show us why in this really interesting, I think, and provocative chapter. So that's the game plan. He's going to explain what eliminative materialism is and why we've had to eliminate obstructive or non-referring or nonsensical terms from our vocabularies in order for the other sciences to evolve, which is what happened historically, and why we have to do this for neuroscience as well. And ultimately, he'll do something that good philosophers always do. He will raise objections to his own argument and respond to them. And this is something you might want to take a hint to do in your own essays. It's always a good policy to present your side of things or your thesis, you know, what you want to argue for, what you want to defend, but it always strengthens your argument if you can anticipate objections that might be made, in particular the strongest of them, and then raise them yourself and answer them. This will always strengthen your position. So this is what he'll do toward the end. We will need to introduce some new vocabulary today, some new concepts in order to follow Churchland, and one comes up right away, and I want to explain what identity theory is, as I'm assuming most of you have not encountered it before, and maybe haven't yet looked it up. You can certainly look it up on the internet, either in the Encyclopedia of Philosophy, the Internet Encyclopedia, as I recommended, or for a more or a deeper explanation, you can look it up in the Stanford Online Encyclopedia, and you'll get a story about what identity theory is in a nutshell. It's not difficult. Difficult to elaborate, not difficult to define. Identity theory basically proposes that there is literally a way in which we can map everything we say about the mind onto some state of the brain. So every mind state would be equivalent or identical to some corresponding brain state and vice versa. So in other words, if you did some imaging of someone's brain and you got a particular image of their brain at a given time, that image would be a kind of have a corresponding mind state associated with it. So whatever was on the person's mind at the time would be influencing the image that you have of their brain at the same time. And you know, conversely, that whatever you happen to be thinking about, or whatever you're thinking about at this moment, is inducing an equivalent state of affairs in your brain, and there's a one-to-one correspondence. And so the idea is, and it's very reasonable on the face of it perhaps, but almost impossible, as he says, for us to actually execute, would be to have this map, to make a complete map of every possible state that your brain could be in, and show how that corresponds to every possible state that your mind could be in, and vice versa. So we talk about mind states and brain states, yes? And again, remember, if I ask you what's on your mind, I'm sure you can tell me. But you would not be able to tell me what your brain was doing while you're telling me what's on your mind, or maybe what you're thinking about. That would obviously be inducing certain states in your brain, or so it would seem to any dualist, since brain and mind are linked. So the identity theory is saying that they're linked very intimately. So that, again, most succinctly, every mind state would be identifiably mapped to a particular brain state and vice versa. And what we'd like to have ultimately would be a complete mapping, right? Or what he calls nice one-to-one matchups. So whatever's on your mind could also be explained in terms of what's going on in your brain. And again, conversely, whatever's going on in your brain would also be reflected or be explicable somehow in terms of what's going on in your mind. So that would be the identity theory full blown. We'd have a complete mapping between the mind on the one hand and the brain on the other. Is that much clearer to you? Everybody okay with that idea? That there's a correspondence, in a sense, between mind and brain? Yes? You okay? Good. Okay. And now that's easier said than done, right? And if you think about it just in terms of the math involved, it's actually almost an impossible task. Let me stop this share for a moment. Yeah, so whatever we say about the mind, that's right, Randy, anything we say about the mind or anything that's on your mind is in a certain sense happening also in your brain. So whatever your mind is doing, your brain is doing. And whenever your mind is in a different state, it must be the case that your brain is in a correspondingly different state. And the identity theory wants to give us that map, which would help explain simultaneously what minds are doing, what brains are doing at any given time. But just to show you how perhaps difficult, daunting, if not impossible this is, here's an example. Here's an example. I just want to share the whiteboard for a moment to give you a sense of just numerically what a incredibly daunting task this would actually be. Let me see if I can come up with that. How do I do, remind me, where's the whiteboard on this thing? I'm sharing that again. But I want to share, actually I want to share the whiteboard with you more. Does anybody remember where the whiteboard is on this thing? I know there's one somewhere.
If you do share screen.
Yep.
Oh yeah, it's next to desktop.
Whiteboard, there it is. Yes, thanks for the reminder. Thank you very much. Problem is I am bouncing around between so many platforms these days that I'm starting to lose track. You know, if I used only one, I would remember where everything was. I'm using so many. Okay, here we go. So let's see if this works. All right, so how many neurons do we have? Anybody know roughly? You know, brain cells, right? Anybody roughly know how many neurons we have in our brains? Of course, at my age, we start to lose them. But normally we have around 86 billion to start with anyway, in a mature brain, around 86 billion. So that around 86 billion neurons in scientific notation, that's a very large number, right? That's basically, if you write it in scientific notation, it's 2 times 10 to the 10th power, yeah? 2 times 10, or what they say now is 2 exponent plus 10, right? That's how you write 86 billion. So if each neuron, that's a huge number. It's almost as many stars as there are in the Milky Way. Now, if every neuron at a given moment can be either on or off, think about it, either a neuron is firing or it isn't. Of course, it's more complicated than this because you have analog states, synapses, where all the neurons join up and meet each other. There are thousands of them impinging on each synapse, and there's a whole bunch of neurochemical transmitters whose levels are constantly changing, and it's the concentrations of neurochemical transmitters at a given synapse that determines whether a particular neuron fires or not, and so forth. It's not a simple business, but if we just think about the neurons alone, then it's a digital network because a neuron is either firing or not firing. And so, I mean, simplistically, we can imagine it to be a digital network. And if every neuron's either firing or not firing, that means in terms of neural states alone, just in terms of neural states alone, that the number of neural states alone is therefore 2 to the power of 86 billion, right? 2 raised to the power of 2 to the 10. So it's 2 to the 2 to the 10, all right? That's how many brain states there are in terms of the neurons. Now it's more complicated because the activity at the synapses is an analog measure, not a digital one. And so you'd have to factor that in. And so if we started, the point of this is that if we started to try to list the number of possible brain states, we would never be able to do it in our lifetimes. We would need many supercomputers networked together just to be able to enumerate all possible brain states. And so that task seems in itself to be almost impossible, just in terms of how many neuronal states we have, right? So that just gives you some idea of the physical brain and how potentially complicated it is, all right? So 100 billion, is the order of the number of neurons, but if each neuron can either be firing or not firing, then the number of brain states is much, much greater than the number of neurons. The number of brain states, if a neuron is either firing or not firing, is 2 to the power of the number of neurons. or 2 to almost the power of 100 billion, which is much more than trillions, Matthias. It is a number that is so large we don't have a name for it. If you try and enter that into your scientific calculators, 2 to the power of 2 to the power of 10, you won't get a number. It'll be out of range. So that's how many brain states we have. And we don't even know how to list them all, let alone, of course, map them onto mind states. Okay? That's right, Randy. That's a huge number of, astronomically huge number of possible brain states. Of course, they're not all possible because you can't have every neuron firing at once. So, or you can't have every neuron not firing at all. So some of those states would be eliminated as impossible states, but in the middle of that, you'd have a huge number of states. So already, if you're trying to approach this from a quantitative point of view and just trying to figure out what are the different brain states and how many are there, that's a task that nobody could reasonably expect to complete. And that's part of what motivates, certainly part of what motivates the critique that comes from Churchland about the impossibility of the identity theory. We can't really find materialistic matchups between brain states and ideational matchups between supposedly corresponding mind states. All right, that's one point. And so it's important to understand this. Eliminative materialism doubts. He says that the correct neuroscientific account of human capacities will produce a neat reduction of our common sense framework. In other words, a common sense framework in which we talk about mind, often in psychological vocabulary, and the neuroscientific framework in which we try and specify exactly what's going on in the brain. This is seemingly an impossible task. So he says we're not going to find these one-to-one matchups, and that's what he says. And also beyond that, something more drastic, he asserts that our common sense psychological framework, the way we ordinarily think about these things with our minds, in terms of our minds, he says it's a false and radically misleading conception of the causes of human behavior and the nature of cognitive activity. In other words, both our epistemology and our ontology and also our sociology and our social psychology is somehow false and misleading because of the way in which we actually describe these phenomena. So eliminative materialism wants to eliminate the language that we use insofar as that language is actually false and misleading. So he's saying that folk psychology is not just an incomplete representation of our inner natures. He's saying something worse than that. He's actually saying, to flip the page, that it's an outright misrepresentation of our internal states and activities. So in other words, the ordinary language that we use when we're trying to describe how we feel or how we think or how we react, any kind of psychological account of ourselves and the world and how we relate to others and so forth. He says these things have become very misleading and they're not really accurate representation of what's going on in our brains. So he says, consequently, we can't expect a truly adequate neuroscientific account of our inner lives to provide theoretical categories that match up nicely with the categories of our common sense framework. Accordingly, he says, we must expect that that older framework, namely the so-called common sense or folk psychological approach, will simply be eliminated rather than reduced by a mature neuroscience, reduced, in other words, to an explanation of brain states. He doesn't think that's going to happen at all. And he wants to show how the history of science has done exactly this, this process of elimination of misleading concepts and terms for them has in fact enabled the progress of the physical sciences. So he thinks it's really necessary for the psychological and ultimately the social sciences to develop the same approach. Again, it's going to be easier said than done, but that's what he's advocating. And here are some very compelling historical parallels. And those of you who study science, you will not have encountered the terminology that he's going to introduce here and remind us of, precisely because the older terminologies which were used to try to explain certain phenomena turned out to be false and were eliminated. And that means eliminated from our vocabulary and eliminated from our textbooks. not in a you know, in a politically coercive way. We're not talking about a state you know, ordered kind of censorship. That's not what we're talking about. We're just saying that communities of scientists themselves, as they realized they had better explanations for things that they were studying, just rejected the older theories, and along with them, the older vocabularies that they used. And the history of science is really as much, if you're interested in it, it's very fascinating. And it's as much a correction of error as it is a discovery of what we would maybe call truth, or at least approaches to truth. Science is not complete. It may never be complete, but it tends to give us better and better explanations for things, hopefully. And in doing so, it's compelled to reject older and more clumsy and maybe simply wrong-headed explanations that at one time were believed, such as the earth being flat, right? To give a trivial example, at some point in human history, probably most people believed that the earth was flat. It seemed like common sense. We know now that it's false, although there are still some flat earth societies around. I don't mean to offend anyone who belongs to a flat earth society. You're perfectly welcome to. But I think there's overwhelming scientific evidence to show us that, in fact, the earth is spherical and not flat at all. So that's how things like flat earth get eliminated, through better and better discoveries about what we're studying. Okay? And here are some other examples you may not have heard of. And remember, these ultimately are going to bear on ontology, because they're going to get rid of entities which were thought to exist and were used or enlisted to explain things, but really didn't do a very good job in the light of further understanding. So, for example, he says, for most of the 18th and 19th centuries, learned people, that means scholars, believed that heat was a subtle fluid held in bodies, much in the way that water is held in a sponge. So they thought if something was hot, it's because it was containing this subtle fluid, and they called it caloric. That was the name they gave to this supposedly fluid substance that bodies contained if they were hot. It was a primitive theory of heat, and it did not take into account what we now know today about molecular vibration and molecular motion, but it was an older theory. And so they came up with this name called caloric, and that referred to this so-called subtle fluid that accounted for things being hot, and that it flowed within a body or from one body to another. And, you know, it produced thermal expansion, melting, boiling, and everything else. But by the end of the last century, well, this is written in the 20th, not the 21st. So by the last century, he means the end of the 19th, not the end of the 20th. So in the late 1900s, in other words, it became abundantly clear that heat was not a substance at all, but just the energy of motion that trillions of jostling molecules make when energy is imparted to a given body. So this new theory at the time, called the Corpuscular Kinetic theory of matter and heat, was of course far more successful than the old one. It gave us a lot of insight into what we call thermodynamics and thermodynamic properties of things, and we have corresponding thermodynamic laws and so forth. And that meant that this term caloric was simply eliminated. Scientists came to agree that there was no such thing as caloric. It was really an attempt to explain something, but it was really, in the end, a figment of people's imaginations. It had no real existence. So what did they do with it? They eliminated it. They said, we'll drop the term. It no longer refers to anything. We understand now heat in a better way, a more sophisticated way. We don't need this explanation of caloric, which moreover is false. There's no such thing as caloric, so it got eliminated. And that's why you don't find it in your chemistry books. If you look, if any of you are doing Chemistry 101, if you look up the index, look for the word caloric, you won't find it there. Or you may find it there in terms of being referred to as an earlier theory, which has been eliminated. Okay, that's the notion of eliminative materialism. Are we clear about how this works? The example of caloric being one. He gives you another one. This is a great one. I love this one. Another word I'll bet many of you have never heard of until this morning. It used to be thought, this is an older theory of combustion, and people didn't have any idea how combustion really worked. They knew how to make fires, right? Our ancestors going back to, hunting and gathering tribes, going back to when we were probably another species, going back to the cave people or whoever lived, a million years ago when hominids were roaming around, not quite human, but a lot of them had figured out how to make fire. Certainly Neanderthals, say 250 or 350,000 years ago, were capable of making fire. And a lot of people who remained isolated from technology are still capable of making fire with flints or fire bows, very, very old and very efficient ways of making fire without necessarily understanding any theory of combustion. But there used to be, again, around the same time, a theory among so-called scientific communities that when something burned, it was giving off a substance called phlogiston. And that was their theory of combustion, again, in the 17th and 18th centuries. So the idea was, it attempted to explain how it was that things burned. They wanted a scientific explanation. So they came up with this idea of a substance called phlogiston. And the theory was, well, if something's burning, it means it's emitting phlogiston. And when does it stop burning? Well, when it's used up all the phlogiston. That's when the fire goes out. When there's no more phlogiston, the fire goes out. Okay, so that was the primitive, although fairly modern, attempt to explain combustion. They even had these very convincing terms. So if you lit a fire in your fireplace and burned wood, and all the wood burned out, you were left with a pile of ashes, right? No more fire. And they would say, well, yeah, those ashes basically are dephlogisticated mass. In other words, this phlogiston was all used up. So what's left is dephlogisticated mass. Sounds very scientific, right? And what is it? It's more nonsense, because we know now, thanks to better chemical theories, of physical theories, that there's no such thing as phlogiston. And so that's not how combustion works. We now understand, thanks to modern chemistry, that combustion is what is it? It's an oxidation reduction process, right? Basically. And so oxidation reduction reactions became almost certainly the correct explanation for combustion. And therefore phlogiston was not only, notice this is really important, phlogiston was not only an incomplete description, it was a radical misdescription. This is his point. As long as people believed that combustion was explained by phlogiston, they would stop looking for a deeper and a more scientifically comprehensible and demonstrable explanation. So if you absorb a term that is ontologically unsound, in the sense that caloric and phlogiston were unsound. In other words, they didn't refer to anything. They only stood for concepts which were actually false. It turns out to be a misdescription, and it's the misdescription that prevents or obstructs further investigation. So it's not just that the description is incomplete somehow, it's that it was radically wrong. It was misleading, and therefore it prevented people, to a certain extent, from penetrating the truth, as it were, of this particular phenomenon. So that's the danger. I hope you're seeing now the danger of accepting a term that purports to stand for something when in fact it may be a figment of people's imagination. Are we clear? Is this all right? Everybody getting this? Let me see. Yes. Okay, very good. Churchland is clear. He's a clear writer. And he's speaking a language, surely, that many of you also understand. I know there are a number of science students in the room, and even those of you who are not majoring in a science, surely you had some high school science. So this is all within your realm of knowledge. And now maybe you have a better understanding of why you never encountered caloric and phlogiston in your introductions to science. They've been eliminated. Okay. And there are more. I think he's really going to hammer his case down with more examples, which is a great way to do it. The next one is prior to Copernicus. He says that before Copernicus's views about our visible solar system and our visible universe, before Copernicus, almost any human who ventured out at night could look up at the starry sphere of the heavens. And if you stayed for more than a few minutes, and you can do this and try this at home, I mean, go outside on a clear night, and you'll see that the stars are revolving or appear to be moving, right, except for the pole star. The North Star stays, in the same place. The Polaris is the name for the North Star, and it stays more or less fixed compared to us. But all the other constellations appear to be revolving around Polaris as time goes, as the night passes. And all the way back to Aristotle, this goes back to Aristotle around 300 and change BC, who in his very primitive theory, Aristotle was a scientist also, but we're not studying too much of his science because it's mostly replaced. Most of it is wrong. But he was an early scientist. He thought that literally we were living inside of an inverted bowl, because we look up at the sky, and he thought the stars were kind of stuck, on the ceiling of this bowl, and the bowl was turning. It was called a starry sphere for this reason. It was thought to be a hemisphere, and the stars were kind of stuck in the top of the bowl, and the bowl was turning around, and that's why the sky looked like it looked, starry sphere of the heavens. And that was the theory that held up for centuries until Copernicus shook everybody up with his observations. And what was the sphere made of? Well, people speculated it was crystal. What made it turn? Maybe the gods. I mean, this was, another question. These were more questions that the starry sphere theory led to. But no one doubted the existence of the starry sphere because we could all observe it, as you can today. But now we have, as you well know, a highly modified conception of why the night sky appears the way it does. We have much deeper understanding of our solar system, of the planets' orbits on their axes, the planets' orbits around the sun's orbit itself. It's moving within the galaxy. We have a much clearer understanding of why the constellations in the night sky appear as they do. And so we jettisoned the starry sphere of the heavens theory, clearly. And he can give you a different example, jumping forward to more perhaps contemporary times. We could talk about the example of witchcraft. And certainly what used to be called witchcraft could be explained. Some of what was called witchcraft was probably some forms of psychosis, what we today would call some kind of mental illnesses, things you might find in the DSM. And people were accused of being possessed, demonic possession. Then you had more politically charged examples like the witch hunts, right? And we still have this word witch hunt today to signify what? A political persecution is often called a witch hunt. But this comes from that older notion of the persecution of witches at different times. And they were often burned at the stake, not just witches, also men, mostly women, though, who were accused of being witches. Men were accused of being warlocks. And in general, mental illness was thought to be possession by demons. And you had to exorcise the demons to cure the person. So they thought, the people who were burning witches at the stake thought they were actually purging their demons, and therefore that their souls would be accepted in heaven. So people thought that by burning them at the stake, they were actually doing them a favor. And that today would be a pretty crazy thought in contemporary society. We certainly wouldn't condone that. But not many hundred years ago, that was a common belief, that people were possessed at times, and that we had to be able to exorcise those demons, not exorcise them, but exorcise them, right? And the Roman Catholic Church, among other religious institutions, developed very elaborate procedures and ceremonies for exorcising demons. We still have a hangover of that. If you think that this is some kind of archaic history coming from a very superstitious time, think twice. What happens? What do we say today when people sneeze? Someone sneezes. What do you say? What do you often say or hear said?
Bless you.
Bless you. Why do we say that when someone sneezes?
I thought it was because like I I heard a theory that it was because like their breath stopped or something, or their lungs stopped breathe. They stopped breathing. I don't know.
No, that's not quite right. I mean, maybe, but get the demons out is what Nama says. Yes, when someone sneezes, literally, it was thought this is a hangover of this time when people were worried about witchcraft and when witches were, at extreme times burned. Now, when people sneeze, the general superstition was that the demons are coming out. You're getting rid of the demons when you sneeze. There was no better explanation for what sneezing is. Now we know sneezing is what? It's some kind of physiological reflex, right? That's precipitated by what? Maybe something in your nose, something in your lungs or in your throat, right? Some foreign matter or whatever it is that's irritating you, or perhaps a cold. But there are much better explanations now as to why that, I'm calling it a physiological response to a stimulus, is unfolding, and it's a sneeze, and it's a reflex of some kind. In the early days, people thought, not so early in history, but we're back to around, let's say, 14th, 15th, 16th century, medieval times, when there were theories of witchcraft, that if somebody sneezed, then they were actually sneezing the demons out of them. And so bless you was what was said to people. And we still say it without even understanding the origin. We're not, thankfully, you're not burning witches anymore. We are doing witch hunts, however. People are being politically persecuted as if they were evil in some way. But that's another part of human nature that Churchland would say is, again, something that's going on in our brains and that needs a deeper explanation than psychological ones. In any case, we no longer believe, most of us, that witches really exist. What do we do with witches now? We dress up at Halloween, right? Some people will put on a witch's costume at Halloween, and there are maybe some movies made like The Witches of Eastwick. There are still covens. There are still some women, particularly, who practice witchcraft in a New Age manifestation of it. There are still witches' covens, but it is seriously doubted, I think, by a majority of people that they actually have any magical powers. All right? I would ask you, maybe, and again, you're free to believe what you wish. I support freedom of belief and freedom of speech. So if you believe there are witches and witches' covens and people flying around on broomsticks, then, I mean, you're welcome to believe it. But I think we've pretty much eliminated witchcraft as a standard explanation for anything that goes on in modern society. I think we have theories of mental illness, theories of hysteria that explain people's reactions to supposed witchcraft, and theories of persecution, which would explain witch hunts. So we no longer take that term seriously, right? So we don't really think there are witches running around out there. And so that term witch no longer refers to a real entity. It's, in other words, been eliminated from our ontology. And Randy points out Wicca and pagan. Yeah, there are definitely returns to these older things. They come around, and there is a culture of Wicca, definitely. And there are also pagan cultures out there, right? And they do subscribe to this. But I would suspect that a majority in a relatively postmodern scientific community do not subscribe to this, all right? And so that term is essentially eliminated as a way of explaining things that people do. I have not seen anywhere a headline of anybody being accused of witchcraft lately. I don't know, I doubt very seriously that any of you have encountered an example in the media of somebody being accused of witchcraft. That would have been a centuries old kind of thing, okay? Fair enough? All right. Good. We're all clear about this, yeah? We had an instance of this in the USA also, right? The witch hunts of Salem, Massachusetts, right? Has anybody read The Crucible by Arthur Miller, the American playwright? Is anybody familiar with this? You have? Good, good. Are you saying yes because you're familiar with the play The Crucible? And if you are, then good for you. And you know that that play was written by Arthur Miller, and it's not just about witchcraft in Salem. That's where the play is set, at the time of the Pilgrims and the time of the witch hunts in Salem, which are sort of infamous episode in American history. But you know that the play itself was a satire. Oh, good for you, Annie Shaw. Yes, it's a satire about the communist witch hunts that took place under McCarthy in the 1950s in this country, where communists were blacklisted. Anybody suspected of being a communist was not allowed to work in Hollywood or get published or work in media. There was a fear of communism. There still is. But there was, in the 1950s, it was right after the Second World War and the rise of Stalin and the Soviet Empire. So there was a tremendous fear of Soviet power and of their intentions. So that was a backlash here against all communists, even those who were not, of course, seeking to undermine the United States of America. And there were Senate hearings, and there was all kinds of stuff going on. And Arthur Miller wrote The Crucible to satirize that and to criticize it as well. Okay, so that was a witch hunt. So now we get the conclusion that all these concepts we've seen, be it caloric or phlogiston or the starry sphere of the night sky or indeed witchcraft, these things, he says, have been eliminated from our scientific vocabularies. And so he now makes a leap and supposes at the bottom of this page, again highlighted, that the concepts of folk psychology, and when we use words like belief, desire, fear, sensation, pain, joy, and so forth, all of these words in our common day speech and things that we constantly enlist to express ourselves, these are concepts of folk psychology, says Churchland, and they await a similar fate. So if I ask you what you believe about a certain thing, you'll be able to tell me. But Churchland will say, yes, but your belief about a certain thing is indicative of a particular brain state. And just by telling me what you believe, I am not going to get any closer to understanding your brain state. And so this sense of defining people according to what they believe and desire and fear and hope is not giving us as clear a picture of their brains as we'd like to have. And only ultimately by eliminating these terms, which he calls folk psychological terms, will we really be able to understand what's going on in the brain. And because he's a materialist, he believes that these words have no more traction ontologically than caloric and phlogiston and the starry sphere and witchcraft. In other words, there isn't really any such thing as a belief. There's only such thing as a state that the brain is in, and how the brain is manipulating data of a certain kind, and what the neurons are doing and what the synapses are doing. What is the neuroelectrical and the neurochemical activity of your brain when you say you believe something? And he thinks that to get to the bottom of beliefs, we actually need to understand what the brain is doing and not to have this language that tries to describe it in very vague and fuzzy terms. So he's saying, Vanessa asks, at any moment when information evolve, our brain will change. Well, it should be obvious that it's true that when you hear something, your brain changes. When you say something, your brain changes. When you dig around in your memory, to come up with something that someone asked you, your brain changes. Our brain is constantly changing. And it's Churchland's contention that really to understand ourselves, we need to understand our brains. And that it's the language and concepts of folk psychology which in some ways are obstructing our deeper understanding of our brains. Is that clear? That's what he's saying. All right, it's very radical. So apparently he and his wife have already gone down this path. They've walked the walk. I haven't met them, but I am told that when Paul and Patricia sit down to eat breakfast, they converse this way. They've eliminated from their vocabularies all these folk psychology terms. So I guess they don't say, how do you feel today? They say, well, what state is your brain in at the moment? And I guess they try and describe it. So they're trying to push the conversation forward onto a more scientific basis and a less folk psychological one. All right. And many of you maybe some of you who are psychology students, you probably know full well that psychology spans a huge space. I mean, psychology is a vastly diverse and complicated array of studies. But there are some psychologists who are very much neuroscientists. I know psychologists who study neuroendocrinology, for example, and neurochemical transmission and other kinds of brain states. So they are psychologists who are neuroscientists, and they work with teams of neuroscientists. There are also psychologists, I mean psychotherapists, for example, who would be working psychologically in a space that's using only concepts of folk psychology, right? Presumably, I don't know, but if you do go for talk to a psychotherapist, I guess you're going to talk about your beliefs, your desires, your fears, your sensations, your pains, your joys, your emotions, right? And so you'd be speaking in a completely, for Churchland, a conceptual space that's folk psychological, but is really not saying what's going on in the brain. And it may or may not surprise some of you that some contemporary neuroscientists have tried to explain religious belief in this way. I mean, if we're trying to explain beliefs in terms of what is your brain doing when you believe something, or you say you believe something, or exercise a belief, what is your brain doing? And that's really the bedrock for Churchland and for all materialists. The mind is just this fuzzy idea that Descartes had, but the brain is really where the action is, and that's what we need to understand. And many materialistic psychologists today are trying to understand religions in terms of brain activity also. So if people say they profess faith or they profess belief of a religious kind, they're also going to assume, as Churchland would, that this signifies something that's going on in their brains, not really in their minds at all. And there's a book out there. There's a book called The God Part of the Brain. I mean, I'm not saying that it's true or false. I don't know. But I mean, I'm giving you I'll type the title in. Maybe one of you or more of you be interested in reading it. And it's a psychologist, a contemporary neuroscientist, who thinks that he's explained religious belief in terms of brain function. So he calls it the God part of the brain, meaning that part of the brain in which apparently religious belief is held and exercised. And that's a theory that is not attempting to discredit a religious belief, but it's attempting to show how religious belief could be reduced to or explained in terms of a particular part of the brain which seems to be active when people manifest religious belief. Of course, this doesn't prove or disprove the existence of God at all, but it is an attempt to understand what the brain is doing when people express religious beliefs. And for materialists, it would only be what the brain is doing, right? A lot of materialists these days are also atheists, so they don't have God in their equation, and they want to explain everything in terms of materialistic theories. So the God part of the brain tries to do that and explain religion in this way. It's very interesting reading. Whether you're religious or not, I think it's very interesting reading. Right? It's only that specific part, Nama, is dealing with religious belief, because we all have a huge number of beliefs that are not religious. Whether religious or not, we all carry around, a whole host of other beliefs about ordinary things, about the news, about politics, about ourselves, about others. We carry around a huge number of beliefs, and they're not religious necessarily. But this book is focused on religion and tries to identify that part of the brain, which apparently in religious people is very active. And so it's possible that if you are religious, then neuroscience could identify or pinpoint a particular part of your brain that's more active than average. Whereas if you're not religious, possibly that part of your brain is not as active at all. I mean, that's what they're attempting to show. Randy asked, does Churchland also state that mind states are not the same between all people? Well, of course. I mean, that's a very deep problem. Actually, Randy, you're asking what turns out to be a really brilliant question. I mean, I know you're very attentive and philosophical anyway. So far, your questions are all interesting. But this one is particularly interesting, and I will explain why. I'm glad you asked it. So again, Randy asks, does Churchland also state that mind states are not the same between all people. He's less interested in that, so he doesn't say that. But a lot of philosophers are worried about this kind of thing we lay awake worrying about. And that mind states, if brain states are different, everybody's brain is in a different state at a different time, and then it's also the case that if the interactive theory is true, the intertheoretic reduction is true, then a different brain state gives rise to a different mind state. So even people who claim that they're having similar mind states might have different brain states when they're claiming it. So to give you a concrete example, Randy and others, let's say that I see something blue and I say, oh, that's a nice shade of blue. And let's say you see the same thing and a bunch of other people say a car goes by and we're all admiring the blue color. We like, it's an interesting color of blue. And we all look at this car going by and we say, that's an interesting color of blue. Okay, we're all saying that, right? We're all saying the same words, that we are all perceiving blue and we all think it's an interesting shade of blue. But there is no guarantee, Randy and others, there's no guarantee at all that we're having the same experience of blue in our minds. Yes? Even though we're saying we see blue, there's no guarantee that your experience of that blue is the same as my experience of that blue. We may use the same word, but actually it might be conveying a different experience. Is that clear? It's very important. Is that clear to you? That we could use the same word to describe a common experience, but we could all still be, in our minds, understanding that or experiencing it in a different way. And also that would imply that our brains are in different states as well. If we're all perceiving the same color in a slightly different way, then it would seem that our brains couldn't possibly be in equivalently identical states. Is that clear? Am I confusing you, or am I raising an interesting philosophical point that even if you agree with somebody that you're both seeing the same thing, you're not necessarily seeing the same thing, right? Because you'd be processing it in a very different way. Yes, it is, Christine. It's a really interesting problem, and philosophers are concerned with this, and psychologists also are concerned with this because it has to do with perception. And even if we claim we have shared perceptions, it's not necessarily true. We could all say we see the same thing or we understand it in the same way, but maybe we don't. And there's no way to know. We do not at the moment have a way to measure, that I know of at least. If you say you see something blue, we don't really know how your visual cortex is assessing it. And if a bunch of people say they see the same shade of blue, we don't really know if there's a same circuit, right? The blue circuit is lit up, as it were, right? That everybody has a blue circuit. And if you see blue, it lights up the blue circuit. And then your mind says, oh, that's blue. We don't know how this works. We're not even sure that if people use the same word, just because they use the same word, they're necessarily experiencing it in the same way. And again, it points to Churchland, I think, because it shows us that we need to understand the brain a lot better in order to explain the inside, if you like, of experience rather than the verbalization. Our verbalization of experience is one thing, so we could say how we feel or what we are experiencing, but what the brain is really doing is a mystery to us. It's our own brain, but we don't know. And it may well be Churchland is correct. Only when we get to the bottom of the neuroscience can we really understand the nature of experience. So Alexandra says, so our feeling's not really a credible. Well, that's what Churchland is saying. Good for you. You're following Churchland down this path. Whether you agree with him or not at the end of the day is up to you, but you need to follow his reasoning. So he's saying, right, when we talk about our feelings, these are just words, he says, which are not really describing what's going on in our brains. And if we really want to understand feelings, we really have to understand their physical things, right? We have words for them, but they're physical things, and there must be different brain states that correspond to different feelings. And until we really understand what the brain is doing, we do not really understand feelings. So talking about our feelings, therefore, as you suggest, Alexandra, is not really a credible scientific way of talking. And that's Churchland's point. That's why he thinks one day, and his wife agrees. I mean, you can read them both. They're both going to say these terms like feelings are folk psychology, and they're not really giving us an understanding. I mean, you could think about it. If you discuss your feelings, you're not really understanding your feelings. So we need to understand the brain, says Churchland, in order to understand our feelings. So now Alexandra asks, so when there is a problem between two people, they experience or remember the issue different. Churchland would say it's just because their brain, absolutely. And it's not a mere thing, it's a really critical thing. Because if people's brains are functioning in a different way in response to, let's say, a particular experience, then this accounts also for their different memories. It's really, and if we want to understand how that works, surely if we want to understand why 12 eyewitnesses supposedly see the same thing but have different memories of it or filter it differently, obviously we need to understand what their brains are doing, right? It's obvious. It's just easier said than done. So are memories credible things? Well, here we go again. See, this leads to a really interesting line of questioning. I'm glad that you're asking these things because it shows that you're realizing that Churchland's leading us down a road where the scenery is so new to us we don't even know what it is yet. Are memories credible things? Let me postulate this, Alexandra and others. These are great questions this morning. I don't think anybody knows what a memory is. If you think about your think about your grandmother, let's say. So is there a grandmother neuron in there when you decide to think about your grandmother? Is there a grandmother neuron that fires, that somehow conjures up a memory, that retrieves a memory and brings it into your mind? Probably not, because people can lose parts of their brain, people can have accidents or strokes and lose part of their brain, but they can recover memory. So memory appears to be mapped. What we do know from contemporary research into memory is that memory is not just stored uniquely in one part of the brain, that the brain has a lot of built-in redundancy, and that memories get mapped all over the place. So if one part of the brain doesn't quite remember, another part of the brain can take over and recall that memory. But actually what a memory is not known by anybody. And I think that Alexandra and others who are interested in this, there's at least one Nobel Prize waiting to be collected for the first person who can actually explain biologically how we code data and store them in our brains. This is a question I've been thinking about all my life, almost to no effect. I haven't gotten anywhere. If I could live my life over again, I mean, I'm happy to be a philosopher more than, but I'm really interested. I would maybe want to next life explore this question of how memory works, because it's obvious that we do have memories, and it's obvious that these memories are formed by our experience, but memories are data and they get stored in the brain. And we know how data gets stored in computers. We can handle data. We understand how data is coded and stored and retrieved. Those things we've engineered, but nobody knows how it's done in the brain and how it's refreshed. Because if data are formed and stored biologically, I mean, our brains are chemical, right? They're neurochemical, electrical devices. And if our brains are storing all this massive data about our own experiences, it must be coded in a certain way in order to be stored. And nobody, to my knowledge, can explain what a memory actually is. So again, memory is a word that signifies something, but we don't really know what. And so according to Churchland, I'm imagining that he would also say memories have to go. They're not memories themselves, but our explanation of memory is part of folk psychology, and it's very primitive. And eventually we're going to eliminate the word memory and come up with a better word or a better explanation. Okay? And Randy asks, is that why smells activate memories? For sure, for sure. Interesting question. All of our senses are capable of activating memories, and it's almost like we don't even control it, right? Suddenly you see or hear or taste or touch or smell something, and it will stimulate a circuit that reminds you immediately of a memory that you've stored, and it will just come up. So we can voluntarily, if I ask you, remember what you had for breakfast today, you could consciously call up that memory, I'm sure. But as you say, Randy, senses, things that we sense just at random can also call up memories without our necessarily controlling it. It's fascinating. This is a fascinating field of scientific study to discover what a memory is, how it's formed, how it's stored, how it's refreshed, how it's retrieved, and why some people, as we get older, forget. It's not like we forget. Some people believe memories are still there, but we're not able to retrieve them as well. In other cases, such as Alzheimer's, where there's severe damage to the brain because of plaque, then it may be that the memory also is destroyed as well. Again, nobody really knows. It's a huge field and a very important one. So, Alexandra says some memories aren't credible sources. Everyone remembers things differently. Yes, and there are also false memories, right? It's not that memories aren't credible, it's that they're filtered, Alexandra. I think that when we experience things, we are also filtering our experience before it gets saved as a memory. I think it's passing through different experiential filters, and therefore also we have established a set of biases. Everybody has them, and these experiences get filtered that way and stored that way, and that's just how we are. So we can't recount things without memories unless they're false memories. And that's right, Renee, memories are never an exact copy. They're an inexact copy. And again, nobody really understands the filtration process, right? When a memory is being formed, in the process of being formed, it's being made into an inexact copy. I think that's exactly right. It's not an exact copy. Maybe there is no exact copy. Maybe experience is so broad and so deep that we could never, it's just too many data points. We could never really take in a whole experience. So maybe we deliberately select particular elements like pixels. You know, we select the pixels that we want to select, and then they get combined into that memory. And maybe the whole experience would be the combination of everybody's memory plus other things that nobody noticed. So maybe experience is a lot richer than we actually experience it as. Event could be more things than we know. And then we have this other complication. Alexandra asks, how can we recount things without memories? Well, we could have false memories. And that's being studied. If you tell children things, that they experience things, and they didn't experience, and they may start to believe that they did. Yeah? And that's called false memory syndrome. And that's very potentially dangerous. To influence people in a way to make them believe certain things happened which didn't happen. That's altering the reality. Okay, Randy asks, so almost picking certain points in the experience to anchor our memory. I think that's what we do, Randy. I think that whatever comes across our perceptual field, you know, we have all these perceptions that are, the senses are active, and whatever we encounter, I think that we're only capable of selecting a certain number of data points, and we do. And maybe we focus on it more, we select more data points, but we basically form a picture of what's happening. It's not really what's happening, it's a picture of what's happening, and that's the picture that we save, okay? That's my naive kind of hand-waving explanation, but nobody really knows for sure. And that's why we need more science. This is Churchland's point. We really need more science in order to understand how these things work. And so that's why just talking about memory, or talking about dreams and things like this, it's useful and necessary for us to do so, but it is surely falling far short of a coherent and complete explanation of what's really happening. And so Churchland hopes that neuroscience is going to give us that explanation one day, and therefore that we can sharpen our vocabularies and eliminate these things that have been misleading us all along. So we have a few minutes left. I'm really glad that you're raising these questions. These are terrific questions. We have time for a few more. Anybody else? We've covered as much of Churchland as I wanted to cover today. I think you get the drift of what he's on to. On Thursday with my own breakout group, and I'm sure with your breakout groups, you're going to cover the objections he raises to his own theory and also the ways in which he answers them, which he's able to do. So this is quite a different philosopher, and I hope an interesting one for you. Any other questions or comments? Is everybody processing this?
Hot chocolate.
I'm sorry? It may be best if you type your question in. Then the mandala effect, when we remember something that is false. Is that what it's called now? The Mandela effect? Rachel, I wasn't aware that it had a name. I know there's some. Yeah? Go ahead.
I just learned about it over the weekend. It blew my mind away.
Right, right. Yeah, we do. And I mean, there's a problem in courts of law. There's a problem in child testimony. When children are used as witnesses in court, you know, as often happens, it's very tricky because they are vulnerable. Children are more vulnerable, and they can be brainwashed into thinking that something happened that didn't. And it's called false memory syndrome, where they can be imbued with memories, let's say, of abuse, which may not be true. Of course, it's unfortunate when they are, if children are abused, it's awful. But maybe they weren't, and maybe they were imbued with the memory because of some reason, you know, legally that it would be useful for them to testify that that happened when it really didn't. And so people can be manipulated. And propaganda manipulates our emotions in the same, not the same way, but in a not dissimilar way, that we can be induced to respond in a very volatile emotional way to an image or to a name or to a slogan or to something through repetitive conditioning. And that leads to a whole other thing called operant conditioning, which some of you may have studied as well. And all of this depends on what's going on in the brain and why our brains are vulnerable to this kind of manipulation. So it is very interesting. And again, you may wake up from a dream thinking it was real, and you know it's not, right? I mean, but at the moment you woke yourself up, maybe you were having such a scary dream that the only way you could relieve the fear is to wake yourself up. We have the power to do that. So we woke up from it because we made ourselves wake up from it, but the fear was real, even though the dream was false, right? And that's food for thought. It means we can experience a real emotion. No one's saying you weren't scared, but the thing that was happening was a figment of your imagination, wasn't it? I mean, in the case of a nightmare, it wasn't really happening, but the emotional response to it was certainly real, correct?
Well, yeah, the thing I learned over the weekend was not so much the individual reprocessing and making false memories. It was the group as a whole, as in the whole world, has false memories, such as, and I have to double check this because it was saying things like in Star Wars, they never said, Luke, I am your father. And there was never hello, Clarice. In the Hannibal, we all just formulated these ideas as a group, as a world, perhaps.
Interesting.
Yeah.
Interesting. And then you have confirmation bias, which works in a parallel way, right, with individuals as well as groups. So yeah, people will imagine something happened, and then it could get reinforced socially, and then everyone simply believes that things happen that way when maybe they didn't happen that way at all. So again, truth is very slippery and very elusive at times. And I hope that's part of the reason for you now. It's becoming clearer while we still teach and study philosophy. It doesn't guarantee we're going to get to the truth, but it's going to make us a lot more careful about assessing our beliefs and why we hold them. And it's going to hopefully help us to find good reasons for believing what we believe, and being willing also to find good reasons to change our beliefs just in case that is warranted. So anyway, that's an interesting point. One more point before we close, Nama, if we can put our thoughts into categorical brain states, would you say it's almost like we are computers with predictable outcomes? Ultimately, yes, Nama, and I think a lot of people think this is our destiny, that we are very sophisticated computing devices, in a way, biological computers. And if we are, then if we are running deterministic programs, then maybe free will is an illusion. That's where this question goes. And maybe we think we have freedom of choice, but actually we don't. And there is some experimental evidence now that's beginning to suggest, by again monitoring brain states, that the brain goes into a certain state before the person chooses what they choose, and then they make their choice, but it's really an echo of what the brain has already done. And so I'm not one to disparage this. I kind of like free will, or at least I like the idea that maybe we have a certain kind of freedom to choose among possible actions, but it may be the case that we are more determined than we'd like to be. And we will just find out. But we're going to continue in this section of the course next week with Alan Turing, who's going to give us just this thesis that actually the brain is a kind of computer. And we're going to see where that leads in terms of our discussion about understanding. Okay? questions will come up that are even more interesting, I think. But that's it for today. I'm glad that you've all got your thinking caps on, and whether it's your minds or your brains, they're obviously working well today, and you're digesting what Churchland has to tell us. So I wish you a very good week, everybody. We'll continue with my group on Thursday and with your groups whenever you meet to finish the Churchland reading. And then next week, we're going to look at Alan Turing, a very famous, also even more famous paper, asking the question whether a machine can think. And that's in your books as well. Okay, so have a good holiday for today and a good week. I will see you all next week, hopefully, some of you on Thursday. And Alan Turing is coming up next Monday. Can a machine think? All right. You're very welcome, everyone. I'm going to stop the recording now, and be safe, be well, and I'll see you all hopefully next Monday.